So hey guys, in this video we are going to talk about combinatorics and especially binomial coefficients and see how we can use the template shown in the left to calculate these binomial coefficients effectively, and after that we'll solve two problems, one from CSES and other from Codeforces, that is E2 of Div 3 round 690. Let's recap our basics. What is binomial coefficients? So a binomial coefficient is represented by NCR, where C denotes choose, and what this means is that what are the total number of ways to choose our objects objects out of n objects. So let's say I have n objects and I want to make decision of choosing r objects from those n objects. Then what are the total number of ways? And this is given by a formula, that is n factorial upon r factorial into n minus r factorial. So let's see this with an example. Let's say I have n equals to 4 and r equals to 2, and let those four choices be A, B, C, D. Then what are the total number of ways of choosing any two choices of these given choices? Then the possible solution would be either I choose AB, AC, AD, or BC, or I can choose BD, or I can choose CD. So how many total possible ways are there? We can see that there are total 1, 2, 3, 4, 5, 6 ways in total of choosing two objects from any given four objects. So let's try to put this in our formula and see whether this works or not. So n factorial would be 4 factorial divided by r factorial would be 2 factorial, and n minus r factorial would be this. Let's expand our formula. It would be n into 3 into 2 into 1 divided by 2 into 1 and 2 into 1. So if we cancel things out, we can see that our formula and our result matches. Now let's see if our formula of NCR is n factorial upon r factorial n minus r factorial, what would be the time complexity if we try to calculate this? The time complexity to calculate n factorial would be n into n minus 1 into, let's say, n minus 2 up to 1. This can be big O of n. Similarly, for r factorial, it could be big O of r, and for n minus r factorial, it could be big O of n minus r. So overall complexity, we can say that to calculate NCR for any given n and r would be big O of n. And let's say I have t test cases, and for each test case I have a different value of n and r. The total time complexity would be big O of t multiplied by big O of n, and in many cases this would lead us to TLE. Now, using the template given on the left, what we can do is we can calculate NCR in big O of 1, and to do that we would need a pre-computation of big O of n that would pre-compute all the n factorials values from 1 to n, and a big O of n pre-computation to calculate inverse factorial for all the n from 1 to n. What I mean with that is that we can treat numerator as factorials and denominators as inverse factorials, and we can then treat NCR as a big O of 1 complexity if we have the numerator and denominator simply picking up from a pre-computed array. We are not going to discuss how this whole template works and how these values are calculated, what's the reason behind this factorial and inverse factorial concept. For that, I'll attach a video for you to learn, because otherwise it would be very long. In this video, we are going to see how we can use this template during contests to solve or upsolve problems. And let's first see whether this template is correct or not. To check whether this template is correct or not, we have a simple problem from CSES problem set that says to calculate binomial coefficients. And in this problem, we have the test cases, and for each test cases, we have to calculate NCR denoted as B and A. Your task is to calculate n binomial coefficient modulo 10 to the power 9 plus 7, and a binomial coefficient A, B can be calculated using the formula a factorial upon b factorial multiplied by a minus b factorial. We assume that a and b are integers and b is smaller than equals to a and greater than equals to 0. Okay, so in this question we have t test cases, and for each test case we have to calculate the binomial coefficient of these. So let's take the input for our test cases. And so while our test cases run, I'll take Rn and R. So before going into the test cases, let's pre-compute our factorial and inverse factorial arrays so that we can use NCR function to calculate the value of n choose r in big O of 1. To pre-compute everything, I'll just call the init NCR function. Let's call that before entering into the test cases. It's called. Now to print NCR value for each test case, I'll just use my function of NCR and provide those values, and let's see out them, and that's all. This is what's needed to calculate the value of NCR. Let's run the test cases. Okay, I'm getting 10 8 26, and in the output it's same. Let's run this whole. Okay, it's all accepted. So this is the template to calculate the n choose r value in multiple test cases. And I have n here as 10 to the power 6, and let's see a problem where the logic revolves around NCR, and then we can use this template to just print our answer by getting to that logic. And to visualize that, let's take this example. In this problem, you are given a sequence A of length n containing an integer 1 to n. The sequence may contain duplicates, okay? Find the find the number of tuples of m elements. Okay, we can select m elements such that the maximum number in tuple differs from the minimum by no more than k. Okay, so we have to choose m elements, and the difference between the maximum number and the minimum number should be less than or smaller than k. This is the whole problem. Okay, let's try to understand this problem via the example provided. We have m equals to 3, k equals to 2, and our array as 1, 2, 4, 3. So I need to find three numbers, three tuples, where the difference of the maximum number and the minimum number is smaller than equals to k, that is smaller than equals to 2. So I can see that I can choose 1, 2, 3, where maximum number is 3 and minimum number is 1, and the difference is 2, which is a valid. And I can also see 2, 4, 3, and here the maximum number is 4 and the minimum number is 2, so the difference is 2, which is also valid. Can I choose 1, 2, 4? The answer is no, because the maximum number minus minimum number gives us 3, which is not valid, that is greater than k. So let's try to solve this problem. Since we need to find the unique tuples, the order of the array does not matter. So let's just make our array sorted so that we can simplify the problem. I'll take the last test case to visualize this. We have uh, n equals to 10, m equals to 4, that I can choose, that means I can choose 4 elements, and k as 3, that is the difference should be smaller than equals to 3. Let's paste the array 5 6 1 3 2 9 8 1 2 4. Okay, let's sort the array because the ordering of tuple does not matter, so it would be 1 1 2 2 3 4 5 6 8 and 9. So to solve this problem, I'll fix each and every index to be the minimum, and for that particular index, I will find the maximum number that will satisfy the condition of max minus min should be greater than equals to 3, that is a k. Okay, so for let's fix our first index. I'll fix index 0, and for index 0, what is the maximum index number that I can choose, so that subtracting 1 from that number will result in a difference of smaller than equals to 3, and that would be from here to here, because 4 minus 1 will give us 3, that is valid, but after that any number greater than 4 will give a invalid result. So I have compulsorily selected 0, the index, and for index 1 to index 5, I have choice of selecting the remaining number of elements. Since our m was 4, the remaining number of element, I can select any 3 of them. What are the total number of remaining elements? 1, 2, 3, 4, 5. So for 0th index, I have 5 valid options, and for 5 valid options, how many I can choose? I can choose 3 because total m4 could be chosen, but I fixed 0, so remaining m minus 1, that is 3 number has to be chosen now. Okay, now do the same thing for index 1. I'll compulsorily fix index 1 as my minimum number, and let's say it is this, and what is the maximum number that I can choose for a valid condition? This one. The answer is I can choose from here to here. Now what are the choices that I can take? I have total 4 choices, and among those 4 choices I have to select 3 numbers, because m is 4 and I have already selected one, so I need to select 3 numbers, any 3 numbers from these choices. I'll just get a valid condition of max minus min is smaller than equals to 3. Okay, let's do the same for this index, second index. And for second index, I can see I can choose from here to this fifth number. 5 minus 2 is 3, that is valid. I again have 4 choices and I can choose 3 elements. For this 2, that is third index, I can choose from here to here. I have 3 valid choices, so 3 valid choices, and among 3 valid choices I have to select 3 numbers. Okay, let's see for this 3, that is in the fourth index. From here to here I can select, again I can see 3 choices remain, and for 3 choices I have to select 3 numbers because m is 4. For this 4 I can select from this range only, so for this 4 I have, and among 2 choices I have to take 3 to make m equals to 4. It is possible, so is it possible to pick 3 objects from given 2 choices? So no, answer is no. Whenever n is smaller than r, our answer is always 0. Okay, keeping that in mind, we'll continue. And for this 5, I can select from here to here. Again, I have 2C3. For this 6, I can select from here to here. Again, 2C3. and for this 8 I can select from here to here, and this time I have only one option and I'll have to make three choices. Okay, so summation of all these possibilities should be our answer for this question. Let's see the result of each. 5c3, 5 factorial divided by 3 factorial, 5 minus 2 factorial, that is equals to 5 into 4 into 3 factorial upon 3 factorial into 2 factorial, 3 cancel, 2 equals to 10. Let's get the answer for this. 4c3, 4 factorial upon 3 factorial into 1 factorial, that is simply 4. Again this gives us 4, 3c3 is 1, 3c3 again is 1, 2c3 is 0, 0, 0, 0, and getting 10 plus 4 plus 4 plus 1, this is 20. And let's see, the answer for last case is 20. So what we observed that in this problem we were given an array. If we sort that array and get the ranges, valid ranges, and in those valid ranges if we are able to make proper NCR choices, we can sum up those NCR choices and choose our choices and just return that as an answer. So let's see how we can use this template in this problem. We have the test cases as, let's remove all this. The problem says that we have t test cases, getting that input, while t minus minus, I'll take an input for n, m, and k. Yeah. I'll have the array as ARR of size n. Let's input the array. Okay. We will now sort the array so that we can get the valid ranges for each I. Okay. Now, so let's say I fix from I equals to 0, and let's say my j is equals to 0 as well, while my j is smaller than n. What I'll do is, if my r of j minus r of I is valid, that is r of j minus r of I is smaller than equals to k, what I'll do is do a j plus plus. Okay. Now what I can observe that if my I is here, my valid j would become 6, because it would be valid till here, and then after an increment it will go here. So the choices I would have would be 1, 2, 3, 4, 5, and I'm at index 6 and index 0. How can I get 5 from index 6 and 0? I can do is what I can do is I can do a 6 minus 0 minus 1. So I can do choice as n equals to j minus I minus 1. And how many numbers I should choose? Since I have fixated on 1, I'll remaining r would be m minus 1, and my answer would be 0 from beginning, and I'll just add answer plus equals to NCR of n and r. Before that, for each test case, before entering, we'll need to init our NCR function. And yeah, I think that's it. And after this happens, we'll just have to increment our I. Here it would be I is smaller than n. Yeah, because we are checking for each I. And when the loop completes, let's see out our answer. And let's run this. It's giving an error. Would be capital M. Need to assign these. K would be capital K, and N would here be capital N. Okay, let's get the sample test cases here. And one thing I missed here is that this shouldn't be a if, this should be a while. That is, till we are getting a arrow of j minus arrow of I, I'll just increment my j, and this j should be smaller than n. Let's run the test cases, and we are getting the output. Let's try to submit, and this is problem E2. Okay. Okay, and we got a wrong answer, and the reason for that is we didn't do a proper modulo operations. So let's do that. Instead of doing a answer plus equals to that NCR, we'll just need to add answer, and this add function internally does the modulo operations for us. That is, for each addition it will perform the modulo M. So run this again, try to submit it again. And yeah, it got accepted. So yeah, in this video we saw that how we can use this NCR template during contests.